Okay, so we started the hour today with 3 questions. The first one, they are supposed to graph 3 sine of 2 theta. All right, so the first point that they're going to get is for basically graphing parent sine. And, oops. So this is 1, this is negative 1, and this is pi over 2, and this is 2 pi, and this is pi, and this is 3 pi over 2. Now, that's parent sine. Now, obviously, it'd be easy to forget some of these changes to the parent. Like this 3, they needed to put a 3 and a negative 3 here. And then they needed to go through and renumber it with this 2 factored in. So they should have divided everything by 2. I like to think of that as timesing by 1/2 on the fractions. And so their final answer should have been 3 on the y-axis, negative 3, and pi over 4, and 2 pi over 4. Can they leave it unreduced? Yeah. 3 pi over 4, and 4 pi over 4. Now, this is worth 2 points. If their wave is correct, if they did the wave right, I'm going to give them a point just for that. Okay, so that everybody probably gets a point that they drew sine correctly. The renumbering is going to be its own separate point. And what if they just screwed up one of these? Well, then I guess we could take off a 1/2 point. Okay, so most people right there just got 2 out of 2, I would think. How many of you, when grading for the other person, you at this point, you need to tell them how many to give themselves for that problem? 1.5, 2? Take your time grading it. Okay, how many of you personally just earned 2 out of 2? Raise your hand if you did. Okay, good. Now, we'll go on to the next one, which was negative cosine of 4 theta minus 2. Now, this one's definitely more complicated, mostly because you have to factor that inside. The 4 factors out, and you have theta minus 2/4. I'd be okay with that, but 2/4 is 1/2, so I think that'd be even better. Now I'm going to graph it. So cosine starts at 1 and then goes down, goes back up again, and it was at 1 and negative 1 are the 2 key spots, and those don't change in this case because there's no stretch factor, there's no change in amplitude. All right, so then the next thing I'd have to do is go through and find these numbers, 2 pi, pi, pi over 2. It's a lot like the other one we just did. But this time, it's a 4, so we're dividing everything by 4, or timesing by 1/4 on the fractions. That leaves us with 1 pi over 8, and then watch how fast this is to count. I don't even really need to think too much. If that's 1 pi over 8, this is 2 pi over 8, this is 3 pi over 8, and this is 4 pi over 8. And can you leave them unreduced? Yeah, I said that was smart. All right, now, one last thing. 2 last things, actually. I'm going to give them, again, 1 easy point just for having graphed the curve cosine correctly, where it starts at 1, it goes down, and comes back up. Okay, if the curve looks good, they get 1 point. Next, you're going to be shifting this thing to the right. This is called the phase shift. Right 1/2. All right, so how far is 1/2? Now this one, I'm going to actually have to admit that I did not expect this to come out this way. I should have thrown a pi in there so that you'd know exactly how far to shift it. So my bad. I wish I would have put a pi in there. In fact, what I'm going to do This'll be pretty easy to change. Everybody right now, before we grade this, you may make this change. We're gonna put a pi here, which means there'll be a pi here, which means that's how far I want you to move it. I want you to move it 1/2 pi. Now, some of you probably assumed that before, but that's not what it actually said until I put the pi in there. Okay, so take your graph, shift it over 1/2 pi, or pi over 2. Okay, I'm sensing that you guys have shifted, you've changed your answers now to reflect that. So how far is pi over 2? Well, if I'm going to say that in terms of pi over 8s, that's 4 pi over 8. You should have moved it over this far. So then the weird part is that your peak, this peak right here, is going to move all the way over there, and it actually isn't going to change a bit. Let me show you. I'm going to move it over. And do you get that it's just part of the wave? If this peak moves from here to here, then you just shifted it right on top of where it used to be. All right, so the key numbers, though, underneath it will need, and again, I've suggested you to count by like pi over 8, so then it's pretty easy to get these key numbers. This would be 5 pi over 8, 6 pi over 8, 7 pi over 8, and 8 pi over 8. Thank you. All right, so next, we have to flip the whole thing. Why? Because of this negative in the front. So this is now flipping over, and wherever it was high, it's now going to be low, and wherever it was 0, it's still 0. Okay, so there's 2 points on this. If they graphed their original cosine properly, that black wave, then they get one of the 2 points. To get the other whole point, it has to be perfect, which is not easy to do, but it would be that blue line with this stuff labeled properly right there. Okay, now please check theirs and try to see if they deserve 1 point because at least they had their cosine graphed right, or 2 points because they did all of the changes correctly. Pause for a second while you give them a score. So somebody asked about grading this, whether you had to have, that's really 2 periods of the graph. Nope, you would not. You would really only have to have from here over, the part I'm putting in a red box here. That's all you really had to have when you were all done. Okay? All right, so I'm curious, how many of you earned 1 point on that one? How many of you earned 2 points on that one? All right. All right, then last but not least, there's another 2-point question, and I tried to make this one easier. Sine of theta minus pi. So first off, you just graph sine. My advice is to draw the sine first and then go back and number it. It's easier to kind of hit the spots. Have to be so careful. Okay, now this thing needs to shift how far? Well, this right here is the phase shift. It needs to go to the right pi. So now I'm going to shift Oh wait, 1 point is just, did you do that correctly? Was your wave right? Then, did you shift it correctly is a different story. And if you shifted it correctly like that, but then didn't label it, you're gonna have to lose some credit because you didn't actually extend your labels like you should have. My advice, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. That makes it super easy to know this one is 5 pi over 2, and this one's 6 pi over 2. Okay, grade theirs for them, please. 2 points possible, 1 for the curve, 1 for the numbering mostly. And that's very common. I heard somebody say, I didn't know you had to extend the numbering over there. Yep, you do. If you don't label it, if you just move it and you don't show what the numbers are underneath it, you're gonna lose points on the test. Better to know that now on a tiny little homework quiz that isn't worth that much. All right, so this was worth 6. If you just would please give yourself, after they've told you what score you've earned there, give yourself a total out of 6 at the top. Then I want you to take this document as it is, and I'm going to have you Dropbox it in. I don't have the Dropbox open right this second, but I'll have you Dropbox this score. Okay? So in a moment, that Dropbox will open up and you'll give yourself that score. Who made at least a 5 or a 6 out of 6? All right, good. Now, next thing. I need to get you into the notes for today. If you haven't already got to the notes for today, please get there quickly. And this is the second page. We've already done plenty of warm-up here. We're going to jump right into graphing secant. And I think you'll find that these are easier than sine and cosine, as long as you know sine and cosine, which I think you just proved you know how to do sine and cosine. So, all right, in a moment I'm going to ask you to show me that you have found this spot. All right, so to graph secant, first of all, you need to know what its sister function is. So you don't really think secant, you think sine. No, wait, sine doesn't go with secant. What goes with secant? Cosine. So actually, I'd like you to graph cosine right now. There's cosine. Now, why the heck am I graphing cosine if I'm supposed to be graphing secant? Because, would you agree that cosine is really 1 over secant? So secant, another way to say that, is 1 over cosine. So we need to know what cosine looks like so that we can do 1 over cosine. All right, what's the one time that can't really exist then? If this is supposed to be 1 over cosine, when's the problem moment? Tyler?
When it hits like 0.
When cosine is 0, you can't have 1 over 0. So you're right. When cosine hits 0, this thing can't exist. That means there's an asymptote right here and here on the secant graph. Now, you guys know that cosine keeps going, right? It doesn't just stop right there. It actually keeps going like this. Oops, doesn't go straight down, Mr. Server. It's a wave. There we go. Do you get that every time cosine hits 0, you'd have another asymptote? So there'd be another one there. There'd be another one there. There's actually an infinite number of asymptotes. It just keeps on hitting it, and every time it hits it is another asymptote. Okay. Then, the other thing that's unique about doing a 1 over kind of a function is, do you get that 1 over something really small? Like 1 over, let's say cosine got really small, and cosine was 1/1000th, or even 10,000th. When you put 1 over 1/10,000th, that flips it and that's 10,000. So as this gets really close to 0, secant will get infinitely big. That's why secant looks like this. And it goes with asymptotic behavior, meaning it gets closer and closer to the asymptotes. It'll go forever downwards there. And then, of course, on this part, it'll go forever upwards, seeking to get closer and closer to the asymptotes. Because as cosine gets really, really small here, it gets close to 0 before it touches 0. 1 over a tiny thing is a really big thing. And why do they actually share these points? Because those are the points 1 and -1. And guess what you get when you put 1 over 1? What is 1 over 1? It's 1. So then they share this point. Because at that exact moment, both secant and cosine are 1. Okay, so I'm going to finish this here. And how much do you need for this to be like a complete graph of secant? Well, you only need 1 up loop and 1 down loop. So like this right here, that would be 1 complete cycle, 1 period of secant. But usually we don't use that frame. Usually we go here at 0 to here, which was 2 pi. And so usually we use this darker red frame and we say only the part in the dark red frame is our secant graph. So I'm just going to erase the other stuff that's outside of that. You don't really need all of that to be secant. It's just between 0 and 2 pi is the most important part. And remember, secant isn't cosine. It's just related to cosine. So I'm going to erase out all of this cosine graph that I had in the first place. And secant is just the blue lines and the asymptotes. So I'm going to put the asymptotes back in there in blue. That is the graph of secant. All right. I'm going to do it one more time, except a lot faster. Here's secant. Here is cosine. Wherever cosine hits, I get asymptotes. And secant rides on the back of its sister function. So it goes up like this, and yeah, there's part here, but you don't really need it. And then this part. And then it goes like this, and like I said, usually we cut it off, and all you have to graph is 1 period of it. So you can just erase this part and that part. And there is the graph of secant. Okay, how about cosecant? Well, it's going to be the exact same process. Cosecant, we have another slide for this, so let's go to the next page. Cosecant. Well, you're going to graph sine, and cosecant is going to ride on the back of its sister function. Wherever sine hits 0, there's asymptotes. Asymptote, asymptote, asymptote. Because why? Because wherever sine was 0, cosecant is 1 over that. 1 over 0 can't exist. And rides on the back of its sister function. The only points that they share are right there and right there, which are where it was 1 and -1, because 1 over 1, still 1. 1 over -1, still -1. And that's cosecant. So what if you needed to change it to be 2 cosecant? Well, then we just change this, instead of being 1, it's now 2. And this spot here where it would have been -1, it's now -2. What if we throw a 4 theta in there? Well, this was pi over 2, 2 pi over 2, 3 pi over 2, and 4 pi over 2. And now I have to times everything, just like the last one, times everything by 4, or sorry, divide everything by 4, because it's on the inside, you don't trust it. So put a 4 in the denominator of everything. And now it's pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Notice I didn't have to actually redraw it at all. When would you ever have to redraw it? If I hate the ones where you have to go, oh, minus pi. Then you have to redraw the whole thing shifted to the right pi. The shifting ones are always the hardest, of course. But that's it. So let's actually do one of your homework problems here. Do I really want to do this one? No, because it's cosine, and we've already done that. So let's instead do some where they're actually the new function. So like before, we want to graph parent cosecant. We'll do this change later, but for right now, just graph parent cosecant. I don't really like this graph paper, but since I know it's cosecant and I know that's related to sine, I'm just going to make my sine, and I encourage you not to worry too much about the little dashed lines, because I never know which ones to use. So I just kind of draw it on there and not worry exactly that you haven't touched a lattice point. Okay, and then I'm going to say that that's 1. Oops. And that's -1. Now I've graphed sine. Well, I'm really bad at get the important spots. 2 pi, pi, 1 pi over 2, 2 pi over 2, 3 pi over 2. I hope you like this new way. 4 pi over 2. I think it's superior. It just isn't reduced. Okay, then I've graphed sine. Now I do cosecant. It rides on the back of its sister function. Asymptote, asymptote, asymptote. Remember me saying that you'd graph sine and cosine a lot? Or I had to graph sine before I got to even start graphing cosecant. But those black loops and the asymptotes, that's cosecant. But wait, now it has to move. It has to move left, because it says plus, pi over 4. Pi over 4 would be the same as, well, if I wanted to make that into, make all of mine into pi over 4s, I could do that. It'd be like times 2 times 2. It's like, that's like 2 pi over 4s. Okay, so that's just helping me see how far that is. So basically, it's like half of one of my marks. My normal mark there is 2 pi over 4, which is like pi over 2, and I want half of that. I want 1 pi over 4. So I'm moving it over about this far, half of a mark. So then everything has to get moved over that far. Don't have any good news. It's just a pain in the neck. You got to take everything on here and move it to the left pi over 4. Okay, so I would just grab everything and move it over. So I guess I'd probably take my sine wave and take it out and redraw it in, moved over. And that's going to look like this in green. I moved everything to the left, yay. Now I gotta move the loops and the asymptotes over. Everything has to get moved over. Asymptotes are now here, here, and here. And then the loops go back on. Now, how far over did I move it? Pi over 4. Then I know that spot right there is negative pi over 4. And now I just got to complete my loops. And there we go. Oh, so messy. At least you have your program you use Notability is easier to erase with than mine is. So I can't erase entire lines. I gotta individually erase every little spot. Okay, and I still haven't finished filling in all of my labeling on the x-axis, but I would. Okay, I think you've got the idea. So, let me ask you this. On this page, is it too much to ask you to do 2 homework questions? I don't feel like that's too much to ask. That's what I'd do if I were you. These are the 2 that are left. So, we already have something in the grade book today for formative, so it's just, you ought to do it because you want to do well on your next test. So, graph those last couple. They start with secant, which really means you'll start graphing. Which one goes with secant? Say it louder. Say it like you mean it. Cosine. Cosine. Good. You start by graphing cosine. And this one, if you can factor it, you should. All right. Just a quick reminder on these that we talked about them briefly the other day. Amplitude on this one is 1. The period on this one, well, they're 2 pi normally, but has it been changed? No, there's no number there, so it's just 2 pi. Horizontal shift is right pi over 3. And the vertical shift, this doesn't have anything outside that's moving it, so none. This one's more interesting because its amplitude's 1, but its period is definitely not 2 pi anymore because of that. And what do we have to do to everything? Multiply it by 2? No. Divide it by 2. A phase shift, only after you've got it factored. Don't think the phase shift is right pi, because it's not. Okay, that's the last of my advice for today. I hope you enjoyed secant, cosecant. Tomorrow we talk tangent. And that's all I got for you for today.